Okay, so hi, my name is Olivias, and so for the DAP project, I have been, I've looked at the at car speeds in Williamstown, and I've been trying, my goal was to determine whether or not a relationship exists between car type, speed, and then time of day. So I looked at a particular location in Williamstown that was convenient for me because, as you will see, I just wanted to give you a visual of where I was. So this is Water Street, and so I camped out in this little parking lot over here, and I was looking at that radar sign, which you may or may not be familiar with. And so essentially where this is on the actual map is heading south through Williamstown to Pittsfield, so is right where it is. And this is just kind of to give you a visual so you know where I was. Okay, going back into this. Essentially, I recorded data from 90 different vehicles, so 30 from each time of day, and I looked at sedans, SUVs, and trucks as my 3 different types of vehicles, and then for the times of day, I did a morning, afternoon, and then late afternoon kind of timing. So, my hypotheses. The speed limit, something that's important to mention, is the speed limit at this radar sign on Water Street is 35 miles an hour. So I thought that was probably a good place to start if I wanted to look at car speed. So that was the variable that I was examining in this particular study. And so my null hypothesis is that mu equals 35. So essentially that the mean average car speed for cars in Williamstown was either 35 miles per hour or lower. My alternative hypothesis was that the average car speed was faster than 35 miles an hour. And I chose to do a one-sided test, get the one-way street, one-sided test, I know. Because I don't really care if the values are less than 35 miles an hour. That doesn't interest me. Like, maybe there's some really crazy psychological reasons for why people are driving slower than speed limit, but that's not something that I wanted to take on in this study. Okay. So, in terms of thinking about my assumptions and conditions, I was a little unsure at the beginning whether or not car speed could really be considered something that's independent, because, you know, when you think about, you know, Water Street is single lane, so what that means is that if there's traffic, the car speeds are you know, could be influenced by each other. So if one car is driving slowly, it's possible that the car behind is also driving slowly. But I observed that because there's so few traffic in Williamstown, that really didn't pose a problem. And as you can see by this histogram, the data that I collected looks pretty normal. It's pretty nearly normal. It's unimodal and relatively symmetrical, slightly skewed to the left. So what were my conclusions? So based off of the data that I collected, I came to a pretty high p-value of 0.683, which essentially means that I failed to reject my null hypothesis, and then we can expect that generally 68% of cars will drive at 35 miles an hour or lower. So actually the drivers in Williamstown pretty much stick to the speed limit or drive slower than that. And okay, so can we make any generalizations about that? I want to say no, because there's a radar sign, and I think that really influences how fast people drive. So kind of psychologically, I feel like we can't really make generalizations about driving patterns. Okay, that's a little cut off, but some questions moving forward. I am interested in looking at kind of the times of day, as you can see from this box plot. You know, you can tell that in the morning there's like a really wide range, or people rushing to work and some people are late. That's something that I'm interested in studying, and I might want to collect more data for that. And similarly, I'm interested in different car types. So for example, you see a lot more trucks in the morning than any time of day, and a lot more sedans in the afternoon. So those are some questions that I am looking forward to exploring in the future. Thank you.